One moment.
Sequences, it just has commas, it's just listing things out. So a series, that does kind of sound like Siri. I get that one. That's pretty close.
Siri. Oh, you were like, oh.
Hey, Siri. So, what we're going to do is we're going to figure out how we can find the sum of a finite series. Okay, if it's an infinite series, an infinite arithmetic series, it's just going to continue on forever. Okay, so this is a finite one to where maybe we would just want the first 20 terms, or the first 100 terms, or something to that effect. Okay, and we want to know what the sum of that is. Now, instead of taking, let's say I want the sum of a 100-term sequence, I don't want to have to find all 100 terms just to add them up. Do you guys?
No.
Nobody does. Nobody wants to sit there and plug in those numbers into an equation, find the terms, then add them up. So there's formulas in place for that. So this thing here, the S of n is the sum of n terms. So the n stands for how many terms are we adding up. So the sum of 100 terms, sum of 20 terms, whatever the case might be. So that's what the S of n stands for. Now the n itself is number of terms. So if we have 20 terms that we want to add together, 20 is my n. A1 still stands for what? And then an is actually going to be the last term in our series. So you need to know the first term, you need to know the last term. You're going to add those up, divide it by 2, multiply it by how many terms you're adding up together. And that's going to give you the actual sum of that amount of terms.
Is that SN?
Yes. So you need to know first term, last term. We may also need, or you will also need, to remember this formula. Does that look familiar?
Yeah, it's from us.
Just from last week, right? That's how you find the actual formula for an arithmetic sequence. So you may actually have to do that sometimes to find the last term. Might actually have to write the formula out to find the last term. Then we can use the sum formula. Okay, so that does happen. You will see that as well. So everybody have that down?
We would just plug in like the last term where n is, right? Like if we had A1 and D, to find AN at the top.
You would plug in everything, yeah.
Okay.
Yeah. All right. So looking at this one, now this is the easier type, to where they actually give you the formula for this series. So the formula for this series is that 3i plus 7. So again, the three things we need to know is how many terms are we adding up, what's our first term, and what's our last term. Now in this case, our last term, instead of writing an there, our last term is going to be that 20, because that's what this is going up to. So that means n is 20, and we're talking about a20 there. So first term, how could I figure that out? Yeah, you just plug in 1, right? You plug in 1 here. So 3 times 1 plus 7 gives us 10. So that's going to be your A1. And then if we want the 20th term, I'm plugging in 20 for I. And that's going to give us 67. So those are the three parts that we need to know in order to find the sum. So our sum here, so the first sum of the first 20 terms is going to be n times 10 plus 67 divided by 2. So do the 10 plus 67, then divide by 2, and then I would multiply by 20. What do we get? 770? Questions there at all? Pretty straightforward. A little bit easier than finding all 20 terms and then adding all 20 terms up. Would you say? Not that that would be hard. That would just take a lot of time. So, have you got that one down?
Yes.
All right. So how about this one? What's the sum of the first 19 terms of this sequence? So again, the three things we need to know how many terms are we adding, what's our first term, and again, what's our last term. So do we know n in this case? 19. Oh. Do we know our first term? 9. And then we're going to have to figure out what the last term is, right? So this would be a situation where we'd use that formula, the a1 plus the n minus 1 times d, which you can honestly just plug in 19 for n, 9 for a1, and then our difference in this case is -7. So you can really just plug that all in. You don't really need the actual formula itself. They're not asking for that. So 9 plus 19 minus 1 times that difference. So what's our last term? Our last term? Or the sum? That's right. Did you do 18 times -7? Then add 9?
Where are you
19 minus 1. There we go. So once we have all three things, we can now find the sum. You're subtracting 7 each time to get to the next term. So that's your difference. So Sn is equal to, again, that 19 times 9 plus -117 all over 2. What are we getting? -1026. Good. So again, if they just give you the sequence or the first however many terms in the sequence, you have to be able to write the equation to find that last term. Okay, and in that equation we can just plug in, we want to know the last term, so that's why we plugged in 19 for n as well. D again is that how much are we adding or subtracting to get to that next term. So it kind of requires what we did last week as well as this new one for those. Questions? Making sense? Okay. So I'll give you a word problem with this. Concert hall has 25 seats in the first row and one more seat for each row after. So it's just building by one. There are 32 rows total, but we want to know how many seats there are in total. So we want to know the sum of all these rows. So if we're starting at 25, adding 1 to it each time, we want to know what's the sum for 32 rows. So that means our n is 32. Our first term is what? 25. And the 32nd term, can we actually figure that out without creating a formula? for this one? If we're only adding 1 each time, what could I add to the 25 to figure out what the last row is going to have? It's 31, but why? Yeah, 25 already counts for 1 row, so there's 31 rows after that. So if I just add 31 to 25, we're going to get what? 56 in the last row. Now you can still do the formula if you want to, but if they're just going up by 1, it makes it pretty straightforward. So to find the sum, again, we have 32 rows, so we're going to take 25 plus 56, divide that by 2, then multiply that by 32 to figure out how many seats there are total. Which is 1,000 what?
I got 1,002.
That's what I got. So, any questions on that? Okay, I only have one other type. Just want to show you guys this because sometimes they do word it a little bit differently or just kind of looks a little different, but it's the same thing. So this is 42 is your first term, 146 is your last term, and 14 is your n. So they give you everything you need to know in that case. You would just have to find the sum. Okay, so just so you saw that as well. But I want to cover this one because they give us our first term, they give us our last term, and they give us the sum. So which part are they missing? The n. So you still have to plug things. Everything we know we can plug in. So it's going to be equal to 690. But we don't know n. So we have 19 plus 96 divided by 2. Now can we pretty easily solve this thing for n? Yeah, simplify the parenthesis, divide it over, and we're going to get our n. If you do that quick, see what you get. So if you're doing it right, you should get the answer of 12. That they had 12 terms to make that sum happen. So, any questions? The arithmetic series. Formulas will be given on Friday for your test. You just have to know which one's which. Like it doesn't say this is the arithmetic series sum formula. You need to know which one's which. It's just a list on the top. You have to know which one to use. Okay? All right.